All right, class. So now I want us to start looking at the next set of problems. So number 11 just asks us to add these two rational expressions together. And so remember, the important thing is when we add or subtract rational expressions is because they're fractions, we got to make sure the bottom numbers are the same. And so in this case, they are. And so once they're the same, well, that just carries over to our answer. And then 13 plus 9 is 22. But the instructions told us to make sure that it was in lowest terms. And if you see, 22 and 4 each have a 2 in common. And so I can divide each one by 2, and I get 11 over 2x squared as my final answer for number 11. Alright, so number 12, it asked me to just perform the indicated operation, which in this case would be to multiply, and then make sure my answer is in lowest terms. So the first thing I need to do is go through and make sure everything is in factored form. So the top part is k plus 2 times k plus 3. And the bottom is k plus 3 times k plus 3. Right. On the right, on the top, the only thing I can do is factor out a k, and that leaves me with k times k plus 3. And then the bottom factors into k plus 2, k plus 2. And so now it's just a matter of crossing off my like terms. And so I have k plus 2 and k plus 2, k plus 3, k plus 3, k plus 3 and another k plus 3. And so the only thing we're left with is k on the top over k plus 2. Nothing else to simplify, and so that's our final answer for number 12. Alright, so now number 13, this is our long one. And so if we notice though that these two are just the same thing, so they cancel each other off. So I can really combine those first two to give me 4x squared minus 19xy minus 5y squared over 12x squared plus 7xy. Let me just rewrite that for you. So plus 7xy plus y squared. Alright, so now we have divided this last term. I'm going to go ahead and change that to multiplication and flip it. And so that would be 15x squared plus 2xy minus y squared over 5x squared minus 24x times y, and then minus 5y squared. Alright, so after we cancel out that, that's what we're left with. So now we just want to factor everything. And so just to save some time, okay, you use Chuck Norris on factoring everything. So I'm going to go ahead and just give you the factored form for everything. And so this top one factors into 4x plus y times x minus 5y. At the bottom, it factors into 3x plus y times 4x plus 1y. Now times, over here the top part factors into 3x plus y times 5x minus y. Alright, so now the bottom part, it factors into 5x plus y times x minus 5y. Alright, so that's all the factored forms. Now we just cross off all the common factors. And so we have 4x plus y, 4x plus y, 3x plus y, 3x plus y, x minus 5y, x minus 5y. And so the only thing we're left with is 5x minus y on the top over 5x plus y on the bottom. And so that's our final answer. Alright, so number 14 was one of those solving systems by, I told you to solve it by elimination. And so what we're trying to do is we're trying to either cancel out the x's or we're trying to cancel out the y's. Well, since the x's, one's positive, one's negative, I'm going to go for that. And so if we look at 7 and 2, we need the common denominator for those, and that's 14. So to get that, I'm going to have to multiply the top equation by 2, and multiply the bottom equation by 7. So multiplying the top one, we get negative 14x plus 14y is equal to negative 42. And then on the bottom, we get 14x plus 21y is equal to negative 63. Now we can add down. The x's cancel. 14y and 21y gives me 35y is equal to negative. Add those together, we get negative 105. Divide by 35. And we get y equals negative 3. Okay, so that's my y value. But now remember, if you get a y, you got to get an x, so we got to take this and plug it back into either one. So I'm just going to plug it into the bottom one. So I get 2x plus 3 times negative 3, because that's what y is, equals negative 9. So that's 2x minus 9 equals negative 9. Add 9 to both sides. I get 2x equals 0. Divide by 2. And so we get x equals 0. So my solution to the system is 0, negative 3. And that's our answer for number 14. Alright, so here we have 15. It's asking us to subtract these two rational expressions. And so again, the first thing we got to do is we got to find an LCD. In order to do that, we got to make sure each denominator is factored. So this one becomes x plus 4, x minus 4. And this one becomes x plus 1, x plus 4. And so then, therefore, our LCD is x plus 4, x minus 4, and x plus 1. Okay. And so now, really, if we look at the first one, we notice that, hey, it's missing the x plus 1 factor, and so that's the one I got to multiply to the top and to the bottom. Then if we look at the second term, it's missing the x minus 4, so that's the one we multiply to the top and also to the bottom. And now they have the same common denominator, and so now we can just simplify it up. So the top over here becomes x squared plus x minus 3x. Let me fix that. So minus 3x plus 12 over the common denominator of x plus 4, x minus 4, and x plus 1. And now if I combine my like terms on the top, I get x squared minus 2x plus 12 over my common denominator of x plus 4, x minus 4, and x plus 1. Alright, and so we really can't factor and simplify it any further, and so that would be our final answer for number 15. Alright, with number 16, we're doing the same thing, adding rational expressions. So finding my LCD, we start with the first one, is just r, go to the next one, it's r minus 5, and so that's my LCD. So the first one is missing the r minus 5, so that's what I multiply to the top and to the bottom. And then the second one is missing just a factor of r, and so that's what we multiply to the top and to the bottom. Okay, but now they have that same common denominator, so now we'll just clean up the tops. That's 2r minus 10 plus 3r, all over that common denominator now of r times r minus 5. And so now, if we combine like terms on the top, we get 5r minus 10 over r times r minus 5. So you can either leave your answer like that. If you want to factor out a 5 on the top, you could get 5 times r minus 2 over r times r minus 5. But that's really all you could do there. So either one of these answers is acceptable as the correct answer. But either way, that's your answer for number 16. Alright, so guys, here we have 17. Again, we're doing the same thing, just kind of adding, subtracting rational expressions. And so what I did, I went ahead and factored that last one anyway, and I saw that it was x minus 1, x minus 3. And so what that tells me is that exactly is what my LCD is x minus 1, x minus 3. So if we look at the first one here, it's missing the x minus 3 factor, so that's the one we're going to multiply it by on the top and the bottom. Okay. The second one's missing the x minus 1, so that's the one it gets multiplied on top and bottom. And then the last one, it's not missing anything, and so we just leave it as it is. We don't have to multiply it by anything. It already has that common denominator of x minus 1, x minus 3. And so now from here, it's just a matter of cleaning this up. And so we're just going to distribute through, clean up the top. So it gives me 5x minus 15 minus x squared plus x squared plus 15 all over the common denominator of x minus 1, x minus 3. So now we see that my x squareds cancel out, my 15s cancel out, and so the only thing we're left with up top is 5x plus x, which is 6x. And on the bottom we have our common denominator of x minus 1 and x minus 3. Nothing else I can do there to simplify that, and so that is your final answer for number 17. Alright, so with number 18 here we have our complex fractions, and so I'm going to use the LCD method to solve this. And so the LCD of all my denominators of 1x, 3, and 6 turns out to just be 6x. And so now we're going to multiply everything by 6x. So multiply my 4 by 6x, the 2x by 6x, x over 3 by 6x, and then lastly the 1/6 by the 6x. And so what we get is 6x times 4 is 24x. And then over on the right, the x's cancel, and 2 times 6 is just 12. On the bottom, 3 becomes 1, 6 becomes 2, so 2x times x is 2x squared. And then the 6's cancel, so plus x. So that's what we get once we first multiply through by the LCD. And now I want to see if I can factor anything. Well, at the top, we can factor a 12 out, and so that leaves me with 2x plus 1. And on the bottom, I can factor an x out, and that leaves me with 2x plus 1. And so now we see we have the common factor of 2x plus 1 on the top and bottom. So they cancel each other off. And so we're just left with 12 over x. And that's our final answer for number 18. Alright, number 19. Again, another complex fraction. This time I'm going to use keep, change, flip. Since I have one nice fraction on the top, one nice fraction on the bottom. Keep, change, flip says we're going to keep the top fraction the way it is. I'm going to turn that division into multiplication. Alright, so we're turning that division into multiplication, and then I'm flipping that bottom fraction, so that would be y minus 3 over 6. And so now we see that we can cross simplify the 9 and the 6. The 6 divided by 3 becomes 2. The 9 divided by 3 becomes 3. And that's really all we can cross simplify. And so on the top we get 3 times y minus 3. And on the bottom we get 2 times y, which is just 2y. And so that's our final answer for number 19. Alright, the last one, number 20, it just says, hey, write this rational expression in lowest terms. So we need to factor it first. And so it looks like the top factors into y plus 6 times y plus 3. And then the bottom factors into y plus 7 times y plus 3. And now if we look, my y plus 3's just cancel each other off. And so we're left with y plus 6 on the top over y plus 7 on the bottom. And that is our final answer for number 20. Alright, so that should be all 20 questions for the Unit 3 test. If you have any other questions, just feel free to email me or come stop by and see me, and I'll be happy to go in more detail with you.